So good afternoon, everyone. I'm going to talk about two tools that we have developed in CIRAD, Montpellier, that are about estimation of risk of introduction and risk of spread or occurrence of a given pathogen in a given country. So first of all, who we are for the people that do not know us. My unit is Unit ASTRE, which is short of Animal Health, Territory and Ecology, Ecosystems. We are based in Montpellier. And our unit is a unit with more than 100 researchers. We are also a collaborating center of VOA, but also a reference lab nationally, internationally for some diseases in animal health. So among the 100 researchers, our small team, Facundo Munoz, which is a statistician, Romain, our geomatician, Cécile Squarzoni, and myself, we have developed two tools that I'm going to present you today, among other research activities that we have in the unit. Among the development of the tools, we have also in CIRAD, and especially our team, a mission to also not just produce, but to train people to use tools and so knowledge transfer more simply. And of course, evolution and update of the tools. So I will present the context, the rationale because of this work. As you know, CIRAD works a lot with countries in development, especially countries in Africa. And many of those countries and many of the health agencies, they do not have the capacities, whether they are budget, whether they are linked to the staff or the skills to deploy an efficient disease surveillance, or not to talk about risk-based surveillance and similar. And they also always express the need to have easy-to-use tools, easy-to-understand tools, because they don't have modeling capacities. And in addition to that, they don't have, since they don't have surveillance, they have very little data about outbreaks or where the disease happens. So we cannot directly apply quantitative methods for disease planning, control and surveillance. But they have a great knowledge of the situation. So if you ask them about the diseases, they know what exactly is happening, what is the host, what is the transmission, etc. They know the seasons. So the space-time epidemiology, they know very well. So we have the domain expertise, and our approach in CIRAD, working with the colleagues, was to deploy a spatial multi-criteria decision analysis, which is a very simple approach, but necessary for some conditions, to estimate risk of introduction and spread of infectious diseases and transform into tools that they can use. So for the ones that do not know, the spatial MCDA, it was also reflected in the presentation of Paolo. It's basically to combine several spatial inputs. We call them risk factors. They can be economic, social, technical, depends on the domain knowledge, and use this domain knowledge to weighting of the factors, combination of the factors to produce some outputs which will be reflected as risk maps. Ideally, we can use seroprevalence data or outbreak data to validate what we obtain with the risk maps with what's happening on the field. That's ideal. So the two freely available are Shiny applications. As I mentioned, they are available to anyone that wants to use them. One is dedicated more to the risk of occurrence or spread in a given territory, so within a country. And the second one is more about estimating the exposure, so the risk of introduction into a given country. So both approaches, let's say, we started working on them and working with the countries since early 2010. MCDA at that point was much in fashion. And at the beginning, we worked with QGIS, training the animal health authorities. And then in 2018, the spread application was developed, and now it's broadly used. The one from introduction, which is a bit more complex also, we just finished the development and now we're in a test phase. So we are testing it among ourselves, even though it's available for you. And we plan to test it with the users, potential users, this year. So let's go into detail for the spread. So I will provide an example just for illustration only. It doesn't represent real data. So imagine that we have a Rift Valley fever in Madagascar. So what do we need for this tool so that it produces a valid response? First of all, we need to have experts, so people that know the epidemiological situation. And what we ask them usually is to describe the epidemiology. So tell us how a Rift Valley fever in Madagascar works. So they will describe the entire cycle. And then we ask them, okay, so which of these factors can be spatially represented? So they will identify them. And we will use them actually as an input to the model. Second important thing is, of course, the spatial units, epidemiological units. So, for example, usually we ask the people those units to correspond to what actually in reality it's the epidemiological units for control or for surveillance. So imagine that this would be AP unit admin level 2, because that's what corresponds to the management of the disease. So they import that into the tool. It can be a GeoJSON file, for example. Then the third step is to import imagine the risk factor, the spatial risk factors. And in this case, on your left, we have the altitude. Imagine that it's chosen. Temporary water bodies distribution and cattle distribution, because we want to estimate the Rift Valley fever in cattle in Madagascar. So they import the raw raster data, and then the tool automatically normalizes this raster data, and at the same time asks the user to identify the relationship. This relationship is, in this tool, linear. It means that the relationship between the factor and the risk, either it's decreasing or increasing, so they choose that. So for example, to illustrate, we can say, well, if altitude increases, the risk decreases because it's a mosquito-borne disease, and I know that at 2,000 meters, for sure I will not find mosquitoes, so the risk decreases. But however, when the altitude is low, the risk is increasing for altitude. Or for temporary water bodies, we can say closer we are to water, the risk is increasing, etc. Or higher density of cattle, the risk increases. In the tool, a user can also enter movement data. So origin, destination can be in a tabular format, exactly like it's presented here. So there's an origin name with latitude and longitude, a destination name with latitude and longitude, and even numbers of animals. It's optional. And then the tool automatically calculates a measure, a centrality measure in network analysis. It's called betweenits. So actually it calculates the nodes, the places, the destinations where they have a high exchange with different places within a country. So this is an example. So when we mix all that, when we import in the tool, a user starts to compare the factors 2 by 2 for who is more important than the other. I will not go into detail, but at the end, if you see on the figure left, we get like weights or contribution of each factor in the overall risk. And that allows the user to get the final risk per administrative unit or even per pixel if rasters were used as input in the model. And then this can be exported as a CSV file or GeoJSON files. He can visualize in QGIS or another tool, or as a CSV file. He has all the names of the epidemiological units, and he can cluster risk, categorize the risk into 1, 3, or several categories, and select maybe the top 3 or the number 5 to prioritize the surveillance. Let's move on to the risk of introduction. I don't know how much time I have left. So this is another tool. That I said that the more recent one and the more, let's say, complex one. So in this example, I will provide again for illustration only foot-and-mouth disease in cattle, imagine in Nigeria. So this tool allows, again, a user to assess the risk of introduction by movement of animals, trade, or whatever in a given country. Imagine we want to estimate that for Nigeria. And there are 2 core data sets that are very important to be imported in the tool, and that is, of course, again, the spatial units for which we want to estimate the risk. So the risk is estimated per spatial unit, not as a country as a whole. Here we can import any spatial unit that we want. Like maybe the spatial units are different, maybe they're at municipal level, or we can choose to link and select from GeoBoundaries API, which is available in the tool. Then the second interesting thing is what we talked yesterday. The tool automatically links the exposure of Nigeria to the WAHIS database, animal surveillance and control measures, to set a score of emission per possible source countries. I will go into detail later. So what actually a user does, he goes in the tool and he says, okay, I want to estimate the risk of introduction and emission from possible source countries for cattle, domestic cattle, and foot-and-mouth disease. Then, these are the measures that are currently used to estimate possible emission risk from possible source countries in Nigeria. So if you can see, the WAHIS database currently, for foot-and-mouth disease in cattle, and using the following measures, following surveillance and control measures, provides information about only 65 countries in the world. So many gray areas. So we don't know what are the surveillance or control measures that are important to estimate this emission risk for many countries in the world. But for some, we know. And in this case, actually, Nigeria doesn't trade with any of those countries. So Nigeria doesn't import, or there is not a transboundary movement with any of those countries. So a user can automatically, well, not automatically, manually in the tool, set, based on his knowledge, a score for each country which is gray. Imagine that Nigeria and the surrounding countries trade with Nigeria, so he can set those values. Then it's not optional, but a user can also import the border points, so it's latitude, longitude points, that can estimate the places where they import. So for example, that can be at the border, but it can be also airports. So if you want to estimate the risk of introduction of a given pathogen and you want to set a monitoring program at an airport or a border, well, you can import those points. And again, I will show you later, a user can associate each point with a source country. So it can help modify the weight the risk of introduction. Then again, even in this tool, we can import animal movement data as a CSV file, again with the same characteristics, origin, destination, and we calculate the in degree in this case. So it's a measure that allows to calculate the nodes where we import or we have most links with outside, let's say, or other data that the user judges as important and relevant for his risk of introduction estimation. It can be either in a raster or vector format. So regarding the entry points, as I mentioned, so a user has the possibility to click on each point and to say, well, this is a legal point of entry, this is a illegal point of entry, and that is taken into account in the model. The same, in that point, he can put the countries with which this point trades or imports. And that directly affects the community that is at the border, or if it's an airport, where the airport is. Then we go to the movement. Again, you don't see it because there are many links, but there are some zones in green behind the dots, which actually, because it's a hypothetical situation, actually they say that, there is no risk there based on the emission countries with which we trade. But the situation can be also changed if a user wants to change. And then at the end, user obtains the final risk. Imagine that this is the situation. And again, you see that for some communities it's a negligible risk, for some it's moderate or low, and for some it's gray. And again, this is because imagine in this situation we have no information if they bring animals from somewhere else, or which are the source countries, and for those countries we don't have information. And like in the previous example, a user can export the results in a tabular format per epi unit and then use further for risk assessment or surveillance and monitoring. So we have applied this approach, as I mentioned at the beginning, for capacity building, but also setting up surveillance plans and validation of the results later on through research, but also operational projects across many countries, more than 20 countries. Africa, Middle East, Transcaucasus, but also Indian Ocean, very recently with the Romain. We continue to provide support to the countries because they like the easiness of using the different tools and how their domain expert knowledge is visual across two tools. However, we must say that as much as appreciated, domain expert knowledge sometimes is subjective. So what one expert thinks it's relevant, another doesn't agree. So we always say to colleagues that they should interpret results with precaution. They cannot say 100% this corresponds to the truth. It will be ideal, and that's what we also recommend, if they go on the field, do some serosurveillance studies, and then get back to confirm or validate the results. So regarding the risk of spread or occurrence, the first tool, note that it currently accepts only linear relationships, so a risk can either increase or decrease. No other relationships, quadratic or other, is accepted. That it's in our to-do list to improve. And of course, the risk of introduction, as I mentioned, we should test with real field data and situations. And the discussion will remain open about linking with the GEOZONE. Currently, the zoning in a given emission country, potential source country, it's not considered. Other surveillance and control measures are considered, but not the zoning. So yes, linking with BAHIS or GEOZONE or whatever, it's an option, and I'm happy to receive ideas. And eventually, I think it's a good idea to merge the two tools into one. So one tool with two possible options for a user, so that at one place we have everything. And at the end, yeah, I'm happy to hear any suggestions, answer any question, but mostly thanks to the team here, Federica, Nicola, Paolo, Matteo, for organizing the event and for hosting us. It was it's a great event, and we learn a lot from all of you. Thank you.
Thank you, Elena. Just only a general idea, okay? According with your experience as a CIRAD, no? When we develop a tool, not you, but also we go for capacity building, we propose a very sometimes model or solutions. Thinking also about GEOZONE and the final meeting we had yesterday. The key words that I would like to keep your attention is the sustainability of tools like the one you presented for the third countries. So we know that there are very few resources. Sometimes you're training the people, then you go next time and appear new people that is different than the previous one. So how can you imagine tool like yours that is very important and very, from technological speaking, producing outcome and essentially support the activity from a technological point of view? What can be the solution to make the tools sustainable for third countries? And keep in mind that we have just finished the GEOZONE.
Again, I don't know, I'm not talking about highly technological tool developed in, I don't know, Java, Python, I don't know, C++. I'm talking about our code. Like we have a statistician, we are epidemiologists, so for us it's even a pleasure, it's a game, let's say, to do. And it's in our mission to, so we know the language. It's in our mission to do activities, so it's not difficult for us. It's an R-Shiny application. It doesn't require, I don't know, special servers or something to do. So it's easy to maintain. And because, again, we are a team of statistician epidemiologists, and because we have retour, how should I say, feedback from the users, We are always interested to improve. And also it raises a lot of also scientific questions later on, or case studies and evolution, that it's also curious and interesting for us as researchers. So the win-win situation is there. We have good collaborations with the countries. They trust, because we are also like you. And that's what I said to Romain. It's noticeable, the passion that you have for developing GEOZONE and all the investment that you did, even with the limitations. And it's good to acknowledge the limitations, because nothing is perfect. So, and I'm sure that whenever you have time and possibility, you will continue to invest your time in GEOZONE as much as we will invest in our tools. It's a method behind, and it's our pleasure.
Honestly,
Yes?
It's my curiosity, because
Yes?
it's something that is running in my mind. When you apply such kind of system, that I agree with you, that are easy to be managed locally without any problem. The problem is if the CVO will accept to use it, to adopt, rather than at their use. Easy. But since there is a lack of data behind, the risk is to add hazards and to have the risk simply as a result of added hazard. Can you follow my idea? So I know that is a problem not to have biosecurity in the farms. So is an hazard. I cannot measure it by now because I don't have the data. And then there is transport movement. I don't know exactly the movement, so it's just an hazard by now because I couldn't estimate the risk. So the problem is when I see such maps, in my mind I have always the question, is added hazards or is a real risk? Okay,
So
I hope
yes,
you catch.
it can be, yes, I agree. I can call it a hazard. But it's a first starting point in a given country. Imagine, I can give an example in Nigeria, very big country. Nothing has been done. They don't have money for surveillance. They want to start somewhere. Where do they start? So sometimes part of these activities are funded by research projects. So we build a project, and then we set a baseline with these hazard maps, let's say. And then within a project and funding, we will go and do surveillance in the country, in the places that identify a higher risk or higher hazard, and some others, so that we use as a control. And we see, but it's a good first starting point. And then the serosurveillance data, we will also use to build another model that is more quantitative and more precise. And then maybe with more information about the farms, the animals, etc., etc. But it's a starting point. And then people, when they see, they like it. Yes, sometimes the acceptance by the CVO, because the pressure is also high. It's not just CIRAD there. You and many other research institutes also offering a lot of trainings all the time for everything. Yes, the same, yes. We too, for the FAO, a big project EUFMD, for example, and then a lot of capacity building, but not just us, you. So yeah, but we try our best, but still the collaboration with some countries that exists and they appreciate a lot. And this trust is something that continues, and I appreciate a lot.
I have another question.
Yes.
Still according with the data problem. In general, in third countries, okay, data is the problem. Also for geographical data, no? Especially the boundaries, administrative divisions. Again, according with your experience, there are some solutions that you can suggest as a CIRAD to resolve this problem, something like create a common repository at global level. I saw that you mentioned a GeoNetwork, but exist other solutions that you can suggest us?
Maybe Romain, he can answer that question more. What I know that, for example, animal movements, that we organize campaigns at markets with the veterinary services so that we collect animal movement data and also transboundary movement data. And that's very difficult, but and it's a very important layer. Because sometimes we can find from the Copernicus or whatever, the big climate data set, land cover data set, we can find those input layers, but they are not enough. So with animal movements and the campaigns that we organize, it's additional and very, very important for disease spread and introduction. So, but Romain, maybe he can mention some other data sets that are produced with the partners on the field that I'm not aware of. But animal movements, yes. Yeah. And we try to tell them, yes, that this can be shared. But it's not our property. Yeah.